name's Katie Monaghan, and my role in the team was project manager.
Hi, I'm Alex Marselek. My job was the MATLAB specialist on Group Q.
Hey, my name's Adel, and my role for the AEV project was SolidWorks.
Hi, my name's Chloe Skinner, and my role in the AEV design project was the organizational manager.
Some of the concepts we kept in mind when making our original sketches included being aerodynamic. That way it would be able to move faster and not waste energy with the air resistance. Also, was very important for us was balance. Balance back and forth could create uneven distribution between the wheels. Another thing was durability. We couldn't have an AEV that was falling apart while we were trying to do our test run. Another thing was the friction between the wheels. Using different arms when we were attaching our AEV to the track created different friction, so we kept that in mind when making our different design sketches. Another thing that was very important to us was that it was lightweight. The heavier it was, the more energy we would have to use to move it forward, stop it, go backwards, and such. So we tried to keep it as lightweight as possible. Another thing we kept in mind was the propeller interference. We couldn't have any pieces right in front of or right behind the propeller where it wouldn't be able to push that air through to get it to move forward. The last thing we kept in mind was it was easily maintained. If it took us several minutes to take it apart or to make any changes on it, we wouldn't be able to enhance our programs and enhance the design of it very efficiently.
My initial concept for our AEV included a slanted surface on the front of the vehicle that the battery and Arduino controller would sit behind, minimizing air resistance and making the vehicle more aerodynamic. I also included one propeller on the front and one on the back of the vehicle. I hoped that this would make our AEV more efficient by making it equally as powerful when traveling forwards as backwards.
The biggest thing to me was to make it as lightweight as possible. You notice in this view that I'm only using the arm and one piece of plastic. This to me was really important to keep it lightweight, so it would have to use less energy to get it to move forward and backwards and get it to stop.
The main intent with my design for the AEV vehicle was finding a vehicle that was aerodynamic. This could be seen with the flaps that come over the front and back, because this would increase the aerodynamic aspect of the vehicle going both in the forward direction and in the reverse direction.
The team's main focus when deciding a final AEV design was energy usage, and weight played a big factor in that because the more weight it needed, the more energy you used to go forward and backwards. And we focused on balance just to make sure that everything was sort of centered and even, and that was another thing that helped out with energy usage. And also just being aerodynamic, like nothing would come in the way while the AEV was in motion. The team chose the first design because it had a much better track test than the second design. The second design could not overcome static friction and did not move at all on the track. Plus, the first design had more balance. Everything was centered for both going forward and backwards. Energy efficiency would be the same. And it was also easier to maintain because we just taped on both the Arduino and the battery onto the monorail arm. So we didn't have to screw it in or do anything like that. Easy for taking it apart. And we also focused heavily on being aerodynamic, and what helped out with that was the fact that the propellers were way below the AEV, so there was no interference with that.
Some of the significant problems we faced throughout our design project were the problem with the Arduino and the energy thing. Our first one said it had like 178 joules. When looking back through the program, however, we realized the delay command was causing an excess of energy that wasn't actually there. But after changing it to the go for command, we didn't face any further problems. Another problem that we encountered was that our second design concept didn't run. It didn't move forward. How we dealt with this was we discussed why it didn't work and continued to enhance our original design and use that for our final project. The third big problem that we faced were inconsistencies with the tracks. Sometimes people would put heavy like AEVs on the track and it would bend the tracks, and there was inconsistencies. So we fixed this by always using the same track, and in some cases we would use the reverse command to have it stop exactly where we needed to. This enhanced our program, and overall it ended up being a success.
Using the engineering design cycle was a big part of this project. The first stage of the design process, up until the preliminary design review, focused on building an AEV concept that we felt would be successful and efficient. We constructed and tested various concepts, analyzing their available power and energy usage until we found one that was successful enough to move on to the next stage. The next stage of the design process focused on working with the Arduino software to write a program which would control our vehicle's movement. We continuously checked and edited our program, analyzing each test's energy consumption and using this information to make changes to our code. This was the most challenging and time-consuming part of the process. The final stage of the design process was final testing, where the team ran their vehicle on the classroom track and were graded on its performance. The team was able to be successful during this stage of the process by using the engineering design cycle and continuously checking and editing their work throughout the entirety of the process.
Through hard work, dedication, and teamwork, Team Q worked together to provide a successful AEV project. Bye!